first few you should be able to take directly from the formula sheet. These are your first few formulas. So this is, we talked about this back in Unit 5. We did this before. The standard deviations formula are only accurate if what? If your 10% rule has been met, okay? All right, if you're talking about proportions, what's the normal check or what's that large count check for proportions? That's the one that's the NP. So in this case here, if we have two samples, it'll be N1 times P1, N1 times 1 minus P1, N2 times P2, N2 times 1 minus P2. All right, so that'll be the greater than 10. If we're talking about means, what's our normal check or our large sample check? So N is greater than 30, Anna. The population is normal, N is greater than 30. You can also look at two graphs, and as long as if your sample's less than 30, and as long as there's no strong skew or outliers, you're good. These right here should have been pretty straightforward. Najee, what'd you get for 3A? Correct, so that's what you got for that one. For B, Ainsley, in the back. Yep, and again, you're fine writing in a scientific notation. Alright, this next one, you should have gotten 0.8467. I wanted you to treat it like a problem from where you're combining the random variables, you're adding them up. So you add up all the means, you add up all the variances, take the square root, and then your normal CDF there. Jen was trying to do a combination of two things, so I thought I would check this. Some of you always want to treat these problems as X bar problems. So, where's the 8.5 and the 9 coming from? This is an easy question.
Problem.
Those are in the problem, right? Those are the numbers I give you the problem. Why am I dividing them by 4? There's 4 packets, so I was trying to find the two averages, right? So you could have said the average is between 2.125 and 2.25, lower bound, upper bound. Then the mean of all the X bars is just equal to mu, and then your standard deviation, you would then 0.08 divided by the square root of 4, and you still would have gotten the same answer. So just, Jen, you see, like you were trying to put the two things together. So you can still do it that way, I just intended you to do it the other way. If you're going to treat the problem as an X bar, make sure every single thing is an X bar then. Your general form for the confidence interval, so it's your statistic plus or minus your critical value times your standard error. Your general form for your test statistics, the statistic minus parameter divided by the standard error. Again, this chapter is very similar to the prior units. The only thing that's different is we have 2 independent samples from different populations. We also are going to include a section on comparing all the tests that you've learned to this point. So there's going to be, on the test, there'll be some multiple choice questions that'll say, here's a scenario, pick the right test. And we'll go over that. Just to remind you, this is your Unit 5 notes. So if you remember, do you remember we did that basketball problem where he had the distraction-free environment and the environment distractions? I gave you the orange cards and you were looking at the difference in the proportions and we were looking at all that. So we kind of have already talked about this 2 sample stuff. Back in those notes, we talked about when we were approximately normal. I showed you where the formulas were derived from. We did a probability problem with it. We did the same thing for the mean. I showed you where the formulas were derived from. We did a problem with it too. All right, so we've kind of seen this stuff before. So,
It says the country of Rwanda wanted to increase the literacy of its school-age children. One possible solution was to provide teacher training for educators. Another possible solution was to pair teacher training with a family community programs to support learning outside the school called LB for Literacy Boost. Researchers randomly assigned students into 3 groups, so the TT, the LB, and a control group that received neither TT nor LB. How will these programs do? Out of the 445 students for the TT program, 219 were promoted to the next grade level. Of 602 students from the LB program, 238 were promoted to the next grade level. Let the PTT, the true proportion of students like the one in the TT program who would be promoted to the next grade level, and PLB be the true proportion of students like the ones in the LB group that would be promoted. This problem is similar. If it asked us to do a confidence interval, and if it asked us to do a significance test, we still have our 4 steps here. It's just that we have 2 samples instead of 1 sample. Your conditions are exactly the same as they were before. This is a proportion. You can see in the problem that it mentions nothing about a mean. It's counting something. So your conditions are the same. You still have your random, you still have your large counts, and you might have your 10%. Maybe not if there's random assignment like there is in this one. The random check here, like that's what I was just referencing there. So you could have the random sample where we would check the 10%, but you can also have random assignment. Now that we're dealing with 2 groups, we're going to see that random assignment more frequently. So if I want to check the conditions for this one right here. So my random check would be yes, they are randomly assigned. My large counts. So the only thing here for the proportion, the checks are a little bit longer here. So you have your, and I'm going to keep the subscripts that they have up here. You could use 1s and 2s, but I'm just going to keep it. So we have the NTT times P hat TT. They already told you what that answer is. It's like the answer to it, the number of people that were promoted is 219. So you have the answer. You don't need to go ahead and recalculate the P hat or anything like that at this point. Then we have the same thing, but 1 minus the P hat. Again, if 219 are going to be promoted, that means 545 minus 219 are not, which gives us 326. And then we have the other one, which is the 238s that were promoted. And this one is the 602 minus the 238. We get 364. Oops. So all of those are at least 10. All right, your 10%. You actually don't have to check it. I will write it here. But because there was random assignment, we can ignore the 10%. The 10% is only referenced if you take a sample from a population without replacement. This problem doesn't really reference getting a sample. It looks like they took this volunteer group of kids and randomly assigned them. So you actually could completely leave that off. That's why I put it in brackets, because it's not really necessary. We good? Alright, you have, so when we did this back in Unit 5, in Unit 5, we were just using this formula right here.
But just like before, when we're trying to create a confidence interval for a difference in proportions, we have a problem. We don't have the p's, so we substitute them with the p hats. So then we call that the standard error. It's the same idea as what we did before. We did it for the one sample stuff, we plugged in the p hat. We're doing the same thing here, we're plugging in the p hats, okay? So we call it the standard error. Again, it's always trying, this is an estimate of the standard deviation. The standard deviation is trying to tell you how far away are those p hat 1s minus p hat 2s from the true difference in the p1 minus the p2. So this is just estimating that. The specific formula and it's, again, the formula is not on the formula sheet exactly. Remember, you have to kind of piece it together. So the formula sheet only tells you for the confidence interval that you have the statistic, which in this case would be p hat 1 minus p hat 2 times the critical value. If it's a proportion, where do we get the critical value? It's z star, so we use the inverse norm, and then times that standard error. So you have to piece it together. So you piece it together. In this case, we don't have just one p hat. We have a p hat 1 minus p hat 2. We have a plus or minus. We have our z star, and there's that standard error formula. Okay? Again, the formula sheet's generic. You put it all together, you get the formula. And then there's two other tips. Oh, there's a calculator command. Now we're in the two sample procedures. I like the calculator over there. I'm gonna have to grab it. So the calculator will always say, for all your two sample procedures, there will always be a 2 in front of them. So this one is a 2 prop z int, okay? Again, the proportion, they always write the word prop up. The two tips here, this tip is the same one that we've seen before. All right, this one here, so this is just talking here about using the calculator versus doing it by hand. And this is where the book kind of recommends you use the calculator, or says your teacher's going to. That formula, it's just a little bit big. You start plugging stuff into it, you're more likely to make an error. Calculator's generally a lot easier. That's why I kind of always steer you towards the calculator. Again, when you're using the calculator, we're always taking that risk that we can't get partial credit because we're not plugging anything into the formula, so you just want to make sure everything else is solid. You could also always just go back and double check that step too. The other tip here, again, when you're defining things, just make sure you're being clear about if you're referencing the sample, which is the hat, or are you referencing the population, which is the one without the hat, okay? Alright, so I will show you formula and calculator here. We're back to the Rwanda. I'm not sure if I can say that right. It says calculate a 90% confidence interval for the difference. Again, that's what we're doing here. We're not adding the two together, we're looking at a difference. We already checked the conditions, so to calculate the interval. Alright, look. This group is first. That's this group right here. This group is second. That's these numbers right here. So, your statistic here. This formula is long, so I'm going to split it in half here, and I'll do the formula up here, and I'll do the calculator command down here. So they want us to do the TT minus the LB. So the TT is the 219 over the 545 minus the 238 over the 602. That's your P hat 1 minus your P hat 2. All right, we have the plus or minus. We are doing a 90%. Anybody remember the Z star for 90%? 1.645. All right. The formula here.
I didn't wanna put that there, I wanna put Z star, I was trying to tell you what the formula was. Alright, so it's the p hat 1 times 1 minus the p hat 1 over n1, so in this case, sorry, I didn't change those into proportions, so I'm using the fractions. I know, so many numbers to write. Kyle just wants to truncate all these numbers. But see, the fractions, like, they're preserving the number, cause you haven't rounded anything yet, or truncated.
Fractions are better.
Fractions are wonderful.
On the AP test, we can just leave it like this because it's all numbers.
Correct.
Wait, can we actually do that for stats? As long as it's all numbers, can you just do that?
Leave your answer like that if that was your answer?
Yeah.
Is that what you're asking?
For even this whole thing?
Yeah.
Yeah. I mean, you're gonna have to plug it in and get the answers. I wouldn't do it this way. I'd use the calc. Let me answer that question in a second, cause I'm not sure exactly what you're asking me. Sorry, that looked kinda messy there. So again, my p hats, I'm leaving them as the fraction, so I have that 238 over 602, and then 1 minus that, but it's all over 602. I'm gonna tell you, now, so this is what the book was saying. You trying to type that into your calculator, you're apt to make a mistake because there's so much going on, especially since I didn't convert these to proportions. I will tell you what the answer is, and then I'm gonna show you the calculator command. So it's negative 0.0411 to 0.0541. And then if I were using the calculator command, you're going to do the same thing that you've done for me from before. Everybody ready? We're going to stat, go all the way over to test. Oh, apparently I thought I plugged it in this calculator, but the battery, I did not get it all the way in there, I guess. Alright, you're looking for the ones that have a 2 in front of them. Again, the calculator doesn't write out the word mean, but it does write out the word prop. Number 6 is your test, that's tomorrow. We go down, we find the interval, B. The x1 is your 219. The n1 is your 545. Alright, just like before, those x's are a count. These have to be whole numbers. If you had a problem that gave you a proportion, like a p hat, and then you got a decimal there, you're going to have to round it to the nearest whole number to make this calculator command work. The calculator knows you're supposed to be counting something. Oops, I was going to put the same number at 238, 602. Again, that sea level you can put it in as 90, you're going to put it in as 0.9. And then we would say, we would write that conclusion statement the same way. I'm 90% confident that the true difference in the P and the PTT minus the TLB is in that interval. I said it a little differently, but it's the same statement we've always been writing. All right, your name of your procedure here. Again, these names are important. You saw in those rubrics, they're always asking you to identify your procedure by name or by formula. Since I'm letting you use the calculator, you got to make sure you identify it by name. They don't want the calculator speak, they want the actual, like this name here. So this method is a 2-sample Z interval for a difference in proportions. So again, we've got 2 samples, we're using the Z distribution, we're creating an interval, it's a difference in proportions. What I did back here is I just summarized everything for you. So again, that first step You know, we want to find the true the 95% confidence interval for the true difference. Again, that first step isn't emphasized quite as much in the older rubrics. It might be in the future ones. You have a 2 samples Z interval for difference in proportions, so we're still going to state it. Remember your random check? You either can have 2 random samples, or maybe you did a random assignment. What you're going to want to say here is you're going to want to make sure that the 2 samples are independent of each other. You don't want it to be the same group of people. So I'm going to make sure that I reference that when I check my random check. Your large counts, again, we're plugging in the p-hats here. We are not in the 1 sample stuff right now. So either you've done a random sample without replacement, you're checking the 10% for all the groups, or both groups. Or you've done random assignments, you're good, you don't have to check it. There's your formula, there's your calculator command, we do the interpretation the same way. Alright, this one right here. Thank you. Why don't you try this one? Alright, why don't you try this one on your own? Go ahead and read it. Try to piece everything together. And then I'll reference a few things after we're done with it.
Is it large counts this time, so large samples?
Correct. I don't know that they'd actually take off if you labeled it wrong, as long as you did the right check.
Well, for this test, I think it's gonna be large counts. What are the other, we had so many large samples for
The mean.
means.
So there's that first step again. You don't have to be like too wordy in that first step, but
We can check the percent.
It's really just assume.
again, you don't have to label the steps either. I'm just doing it for you right now, and I'm doing them in different colors too, so you can see. It's okay when you do that large counts if you get a decimal there, just when you plug it into the calculator, you're gonna have to round that decimal. And again, make sure you at least show what the answer is. You don't necessarily have to show, this is just, I know that we talk about always trying to show your work, but this is part of a bigger problem, so it's okay to maybe not show that work, but make sure you show the answer. Don't just say that it's greater than equal to 10. You gotta show that you actually checked it.
Be 3646 times. Did you just write this as a 3.276? We need to use this one. We need to use the decimals.
Yeah, we use this, you just have to round it.
You have to write it?
Remember, the calculator is expecting it counts. You don't have to round it in the large counts check, but you need to round it, right, you need to round it when you use the, pass. And then when you are rounding in that calculator step, you can just round it to the nearest whole number. I put yellow boxes around some things just because I want to make sure you're emphasizing those things. So, like, you wanna make sure that this particular problem told us the direction, they told us they wanted us to do younger minus older, so if a problem doesn't tell you that, you want to make sure you're telling the reader which way you did the subtraction. So you can talk about it in step 1, you can talk about it in step 4, okay? The other thing I want you to make sure is in that random check, make sure you're saying that the two samples are independent of each other. It's said it in the problem, but just make sure you're referencing that just in case, because that's what they're gonna look for in the check. Again, the large counts, you're totally fine leaving those with a decimal, but when you plug it into the calculator, you're gonna have to round it because the calculator is expecting a whole number. If you give the calculator a decimal there, it's gonna give you an error message. And again, down here, reference the way we did the subtraction. I believe there's a problem, there's a question at the top of the next page, if you're good here.
I agree with your preference. Is that really convincing evidence of major difference between the two? But like,
It's 8% to 12%.
8%.
Remember, those are percentages. Again, there's a number that we're looking for. What number are we looking in that in the interval? 0, yes. So if 0's in the interval, that would suggest there's no difference. Is 0 in this interval? No, so it suggests there is a difference. Again, 0's, you're subtracting two things. If they were the same, you'd have 0. Back in the Rwanda problem, we did have a negative to a positive, so there may have been no difference there. So again, in this one, 0's not in the interval, so yes, there is convincing evidence because 0's not in the interval. So again, when 0 is in the interval, that's suggesting it's possible that there is a difference. The caution though, so never say that you believe the difference between the two proportions is 0 just because 0 is the interval. Like, so we don't know that it definitely is 0, but we can say that it's possible there's no difference, okay? All right, any questions on any of that? Like I said, it's very similar, it's just some of the checks are a little bit different. So tomorrow, I have a couple other things I need to talk to you about, but tomorrow we'll do the significant